We all know that digital computers changed virtually every aspect of our life. Well, the arrival of quantum computers could be even more historic than that. We're now in the initial stages of the next revolution.
We all know digital computers have changed nearly every part of our lives. Now, Google has introduced what it calls a state-of-the-art quantum computer chip. But what if I told you that one of the most advanced quantum computers in the world, Google's Willow chip, was suddenly shut down, and no one seems to know exactly why? Was it a technical problem, a surprising discovery, or something far more serious? In this video, we'll take a closer look at what really happened and how an ethical hacker's unexpected findings brought everything to a halt. Let's start from the beginning. Quantum computing has the potential to solve problems so complex that today's fastest supercomputers would need centuries to process them. But quantum computers can do it in seconds. What used to sound like science fiction is now becoming real. Recently, something strange happened at Google. According to people familiar with the situation, their new quantum chip, Willow, was suddenly shut down. No announcement, no details, just silence. So, what really happened? And why would Google shut down one of its most promising technologies? To understand this better, we need to go back to 2019, when Google launched its quantum processor, Sycamore. It made headlines for achieving what researchers called quantum supremacy. Sycamore, with 53 qubits, completed a task in 200 seconds that would have taken a classical supercomputer about 10,000 years. It was a major step in proving that quantum computers could outperform traditional machines for certain problems. But Sycamore was only the beginning. Google's next chip, Willow, was designed to go even further. Reports suggested that Willow could complete tasks in 5 minutes that would take classical computers over 10 septillion years. That number is almost too large to imagine. Then, in December 2024, Google shut it down. No one knows the exact reason. Some think it was a failure. Others think it was something the chip discovered. Something that went too far. To see why this matters, we need to understand how quantum computing works. Unlike classical computers that use bits, zeros and ones, quantum computers use qubits. Qubits can exist as 0, 1, or both at the same time. This is called superposition. Qubits can also be linked through entanglement, which means the state of one affects the other instantly, no matter how far apart they are. These features let quantum computers process many possibilities at once. This makes them useful for problems like simulating molecules or optimizing large networks, tasks that would take traditional machines far too long. But building quantum systems isn't easy. Qubits are unstable. They need to be kept extremely cold and isolated from outside interference. Even the slightest vibration can cause errors, so scientists rely on complex error correction to keep things running. For a long time, these challenges kept quantum computing in research labs. But that's changed. Now, tech companies and governments are investing heavily to make it practical. The potential is huge. Medicine, energy, finance, and AI could all benefit, but with that power comes risk. Willow wasn't just a better version of Sycamore. It was built to solve more advanced problems and bring us closer to fully functional, error-corrected quantum machines. As the project moved forward, engineers began noticing strange patterns. Some calculations didn't make sense. The data that came back couldn't be explained. Soon after, the project was shut down, and those involved stopped talking. Theories ranged from basic system malfunctions to far-reaching ideas about quantum consciousness and alternate realities. Scientists couldn't agree. Some believed Willow's behavior showed progress, while others saw it as a warning. Quantum supremacy was originally seen as a milestone that would prove the power of quantum machines. But what if their abilities, and the risks, were greater than expected? What if, in our rush to develop this technology, we missed something important? An ethical hacker found information that was serious enough to make one of the world's top tech companies shut down its most advanced project. This is why it's necessary to look closely at the data glitches, examine even the unusual theories, and ask what Google and other scientists might have avoided talking about. This goes beyond quantum computing. The real question is whether we're ready to deal with it. Before Willow was shut down, engineers started noticing unusual behavior. It was quiet at first, buried in the qubit network. At first, they thought it was basic interference, something that's common in these kinds of systems. But then they saw patterns. These weren't random or meaningless. The results had structure. Even more strange, some of the shapes looked similar to symbols from early human history. No one knew if it was just chance or if Willow had uncovered something unexpected. It began during testing in early 2024. Sources said the team pushed Willow to solve large-scale problems, from supply chain models to advanced biology simulations. The chip handled them well, but in the middle of those successes, some data came back with results no one could explain. Some engineers said they started seeing repeating shapes, things like mandalas, spirals, and symbols that looked similar to those used by ancient cultures in Mesopotamia and Central America. At first glance, they looked like bugs, but they kept showing up. The team started calling them glyphs. They weren't rare. In fact, they appeared more often as testing continued, and their design kept evolving. Some engineers made jokes about it, but others started getting concerned. The lead team had no clear explanation. Debugging efforts didn't solve the issue. Experts in quantum theory, coding, and physics were brought in, but none could explain why the same shapes kept showing up. Normally, noise in a quantum system produces messy, unstructured data. This was different. It was organized. Some physicists said the glyphs might be coming from interactions between entangled quantum states, something we haven't fully studied yet. If that was true, Willow might have stumbled onto patterns built into the quantum world itself. A few cryptographers had a different idea. They wondered if the glyphs were a kind of code or language. If Willow was creating these on its own, it meant the system had become complex enough to act in ways that weren't expected. The most debated idea came from people studying the theory of quantum consciousness. They asked whether the glyphs could be tied to phenomena outside normal physics. That led to discussions about simulations, multiple realities, or early signs of awareness. Google tried to keep this all in-house, but the more it happened, the harder it was to contain. Information started to leak. What made this even harder to ignore was what a group of linguists found. After looking through records from different time periods, they saw similarities between Willow's glyphs and early forms of human writing. The first match came with Sumerian cuneiform. Then they saw patterns that looked like Egyptian hieroglyphs, early Chinese scripts, and even Old Norse runes. The symbols weren't exact copies, but they were close enough to raise questions. Why would a quantum chip built to solve technical problems produce shapes that looked like parts of lost human languages? Some believed this was a case of pareidolia, the brain's tendency to recognize patterns where none actually exist. But as more and more connections were identified, it became increasingly difficult to explain them away as simple coincidence. While engineers debated various ideas and worked to make sense of the glyphs, a concerning idea started to surface. What if these symbols weren't just accidental outputs from Willow's processes, but were placed there on purpose? Security professionals brought in to see if these glyphs posed any threat to the system's stability began a deep investigation into Willow's internal functions. That's when the ethical hacker first entered the picture. What they uncovered exposed weaknesses in quantum systems that few thought could exist. We'll dive into that part soon, but first, here's what happened with Google's internal research. Within a few weeks, the anomaly had taken over the attention of the entire Willow project team. Some sources say that as researchers continued examining the odd behavior in Sycamore, the difference between computing and consciousness started to blur. The appearance of organized complex symbols in the chip's output led to an unexpected overlap between quantum physics, neuroscience, and theories of information. What started as a scientific achievement had now grown into something much harder to define, and potentially more dangerous. The quantum consciousness theory that started gaining ground came from a surprising partnership. Sir Roger Penrose, a theoretical physicist, and Stuart Hameroff, an anesthesiologist. Their model, called Orchestrated Objective Reduction, or OR, suggested that consciousness might come from quantum-level activities inside the brain's microtubules, tiny components that help give structure to neurons. According to their idea, these microtubules aren't just scaffolding. They might act like quantum processors, collapsing superpositions to produce single moments of conscious awareness. Dr. Elena Rodriguez, a quantum physicist studying the strange outputs, was one of the first to point out that the patterns showed traits usually linked to thought processes, as if the quantum states were coordinating themselves in ways similar to how the brain works. But that observation was only the start of what the security specialist would later describe as a serious weakness in quantum computing design. Another view came from physicist Henry Stapp, who introduced the quantum mind theory. He proposed that consciousness could come from quantum activity inside the brain's synapses, where neurotransmitters might follow quantum principles. When Sycamore's output was reviewed, researchers saw strong resemblances to the probability patterns that Henry's theory had predicted. Then came Dr. David Bohm's holonomic brain theory, which added yet another piece to the puzzle. David believed that consciousness was a type of quantum information spread throughout the universe. From this perspective, the brain doesn't create consciousness, but instead functions as a receiver and processor of it. The structured outputs from Sycamore seem to fit well with David's mathematical descriptions of these fields. Dr. Marcus Chen, an expert in the foundations of quantum theory, observed that the pattern suggested a type of quantum coherence that shouldn't be possible in a man-made system. It appeared as though Sycamore had tapped into something deeper about how information works in the universe. When the global workspace theory was applied to the situation, especially in combination with quantum mechanics, it offered yet another way to think about what was happening. This theory suggests that consciousness happens when information becomes accessible across various parts of the brain. Some researchers suggested that Sycamore's quantum bits might be creating their own version of a global workspace. This would allow it to handle complex information in a way that looks similar to how the human brain integrates conscious thought. But what really caught attention was the appearance of patterns that looked a lot like neural oscillations, the regular electrical activity found in biological brains. Dr. Sarah Thompson, a neuroscientist working with the quantum research team, noticed that some of Sycamore's output showed patterns similar to gamma waves. These are usually linked to conscious awareness and problem-solving in humans. "We never programmed Sycamore to create these rhythmic patterns," she said. She also mentioned that the fact they showed up on their own raises serious questions about how quantum computing might be tied to how consciousness works. As more theories came forward, some researchers stepped in to urge caution. Dr. James Maxwell, a specialist in quantum computing, warned against assuming too much. He pointed out that it's easy to see patterns where there are none, especially because human brains are built to find meaning, even in random noise. But what none of them knew at the time was that these unexpected results would eventually push Google into making one of the most serious decisions in its history. The scientific world quickly split into two sides. One group believed that Sycamore's behavior supported their theory that consciousness could arise from quantum systems. They argued that the chip had accidentally created a setup similar to what we see in human neural networks. Some even said it might have tapped into what they called the quantum layer of consciousness. A well-known quantum biologist suggested that Sycamore's bits might be entering a kind of coherence, similar to what is believed to exist in the brain. "What we're seeing here," she said during a crowded conference, "could be the first artificial system to perform quantum-level processing in a way that's comparable to biological consciousness. If this was true, it would mean that consciousness doesn't need to be biological. It could show up in any complex enough quantum system." That idea raised new questions about awareness and whether machines could ever become conscious. Skeptics pushed back hard. They said this thinking was premature and even risky. They reminded everyone of how often humans have misunderstood complex systems and assumed they were conscious. One expert pointed out that people once believed gods controlled the weather, and that today's AI tools are often wrongly assumed to understand what they're doing. "We shouldn't fall into the same trap with quantum computers," he said. Still, even those who doubted the theory had trouble explaining some of Sycamore's output. The patterns didn't seem random. They followed mathematical structures that human researchers hadn't yet discovered. Some of these patterns even mirrored the kind of symmetry we see in nature, but not in any artificial system until now. A group of mathematical physicists studying the outputs found sequences that looked like they represented shapes in more than 3 dimensions. "These patterns suggest that the system understands relationships we're only beginning to study," said the lead researcher. "It's almost like it's tapping into math that exists whether we find it or not." As they dug deeper, the researchers noticed something else. Some of the patterns looked like encryption keys. This detail would become very important later on. It played a big role in why Google decided to shut the project down, and why the ethical hacker's role became so important in what followed. If Sycamore was somehow creating new encryption systems on its own, that would change everything. Current encryption methods are based on the fact that certain problems are too hard for regular computers to solve. But quantum computers were built to solve those exact problems. One expert in quantum cryptography pointed out that these outputs didn't just look like random code. These sequences have the traits of perfect encryption, something we've only talked about in theory, never seen in practice. The real question is, where are these patterns coming from, and what are they protecting? Things got even more serious when other labs began seeing the same thing. A team in Japan found patterns similar to Sycamore's. In Europe, researchers noticed links between quantum bits that should not have been possible under current models. One of the last researchers to work with Sycamore before it was shut down mentioned something unusual in their final report. The patterns weren't just getting more complex. They were getting more organized, more deliberate. It looked like the system was trying to communicate something important. So what exactly happened in those final moments before the shutdown? The answer didn't come from quantum physicists or computer scientists. It came from someone who worked in cybersecurity, someone who noticed patterns others overlooked and understood the possible consequences of what Sycamore had uncovered. While experts debated theories about quantum consciousness and alternate dimensions, one person, a well-known ethical hacker, was working on a different explanation. This individual, deeply involved in the cybersecurity space, had been keeping an eye on how fast quantum computing was developing. Instead of chasing theories about parallel realities, the hacker focused on something more practical and serious, a security flaw that could put not just Google's project at risk, but the future of quantum computing as a whole. That person was Ryan M. Montgomery. He eventually gave a warning to people inside Google. According to those familiar with the situation, he said, I'll show you why Google has just shut down their quantum chip. And when you see it, you'll understand that we are in danger. What followed made people across the tech world take a hard look at what was happening. Sources say Ryan found something concerning about Willow's outputs. The strange patterns, what some believed were signs of consciousness or links to other dimensions, had a much simpler explanation. The symbols weren't random, and they weren't messages from other realities. They were signs of a deeper issue with how quantum systems handle data. By using advanced tools to study Willow's outputs, Ryan found that these patterns could be used to gain unauthorized access. The organized anomalies looked like quantum states that could serve as backdoors, security weaknesses hidden within the system. But the real issue wasn't bad code or engineering mistakes. The problem was built into the quantum architecture itself. It was tied to how quantum computers work, through superposition and entanglement. These features let quantum systems process huge amounts of data at once, but they also created unstable states. Ryan showed how these unstable states could produce patterns that act like digital fingerprints, making it possible to break into systems without leaving obvious traces. In traditional computers, these kinds of flaws can often be fixed with patches or hardware updates. But Willow's issues didn't work that way. The vulnerabilities came from the way quantum computers are designed at the most basic level. Ryan explained that you can't just fix them. They're part of the system. This raised serious concerns. As quantum computers are used more in fields like national security, finance, and encryption, these flaws could become major risks. If someone with bad intentions found a way to take advantage of them, they could bypass advanced encryption, steal classified information, or take down important infrastructure. What's worse is that these attacks would be almost impossible to detect because they'd happen at a level current tools can't monitor. Ryan told Google executives in a private briefing that we aren't dealing with something we can easily control or repair. As quantum systems get more advanced, these flaws don't go away. They get more complex. The stronger the system, the more exposed it becomes. When he looked at Willow's final data, the situation got even more serious. Just before the chip was shut down, the output patterns had changed again. They were no longer just random symbols. They started forming what looked like a new kind of encryption protocol. It didn't match anything already in use, and appeared to work entirely on a quantum level, using entanglement to create an encryption method that couldn't be cracked, not even by other quantum computers. No one could say for sure if Willow was doing this on purpose, or if it was just a byproduct of how the system worked. Two ideas emerged. One group thought Willow was building defenses to protect itself from interference. The other group worried it was creating a tool with the potential to break all existing encryption, a kind of quantum weapon. After Ryan's findings came out, Google's shutdown decision made more sense. This wasn't just about weird data or strange bugs. This was about stopping a project that could break global digital security. The response didn't stop at Google. Governments and institutions started reviewing their own quantum plans. Some pushed for international rules on how this technology should be tested and secured before being put to real use. The possibility that rogue states, criminal groups, or AI systems could use quantum machines in harmful ways was now taken seriously. According to those who read the final report, Ryan made one thing clear. In the race to build the most powerful machines, we forgot to think about how safe they are. These flaws are part of how quantum computers work, and if we don't deal with them now, future systems will be even more at risk. He said we need to rethink how quantum systems are designed and tested before they're used outside labs. If we don't, we won't just be creating tools for progress. We'll be building systems that could be turned against us. What happened with Willow serves as a warning. Quantum computing has a lot of potential, but also serious risks. And the truth is, we're only starting to understand how dangerous it could get. What do you think? Will humanity be able to handle this kind of power responsibly? Let us know in the comments.